Hello, this is Mr. Graves. Good to see you. Sorry that I've got to teach you kind of this way. Take your book, go to 7.2 for the first class. Solving simple systems by substitution. Good to see you, and hope you're doing well. I miss you guys. I'm going to just explain. I'm sorry that I don't have a whiteboard, but I'm going to explain a few things to you. Take a look at example 1. We're going to try to find x and y with two different equations, and we're going to find the x and y that actually solves both equations, okay? So x plus y equals 5 and y equals negative 3x plus 7. Now it's called substitution because what ends up happening is we substitute a letter for whatever that is, okay? So if you take a look at example 1, what are they doing? X plus y equals 5 and y equals negative 3x plus 7. So when you go to x plus y equals 5, instead of writing the y, they're going to write negative 3x plus 7, okay? And what you have to do is put that in parentheses. So x plus, and then you see the line there, the second line under where it says answer. You got to follow along in the book with me, okay? X plus, and then it says negative 3x plus 7. Okay, equals 5. Now that's distributive property. You got to use your parentheses, but even though that you have a plus there, you just drop the parentheses. So you have 1x minus 3x, which is a negative 2x, and then plus the 7 there. So negative 2x plus 7 equals 5. It's a regular equation, and all you're going to do is solve for x. And then when you get x, you're going to plug it back in. So x plus y equals 5 ends up being 1. Then y has to be 4. So your answer is 1 comma 4, okay? So it's important that you understand that. If you look at example 2, x plus y equals a negative 4, x minus y equals 10. So what you have to do is take one of the equations and get a letter by itself and then substitute that letter, okay? Looks like what your book did is it left x plus y equals negative 4, or actually it changed it. So it kept x minus y equals 10, and then what it did is it changed it to x equals negative y minus 4, okay? So it subtracted y from both sides, put the y in front is what it did, okay? Now, what's going to happen is, I'm going to show you in your examples. I'm going to have you do probably 1 through 16 over the next couple days. Number 1, take a look at your homework, okay, so that you can kind of see it. Number 1, x plus 2y equals 11. 3x plus 5y equals 17. Let me see, matching, choose the best. And actually, go to 5 to 16. Sorry about that. Go 5 to 16, okay, instead. So number 5, y equals 3x. 4x plus y equals 49. So that means if y is equal to 3x, then instead of writing the y in the second equation, you're going to write 4x plus, and then instead of writing y, you're going to write 3x. So 4x plus 3x equals 49, and you get 7x equals 49, x equals 7, and then you take the 7, you plug it back into x, and then you get yourself the y, okay? So make sure that you do that. Number 6, y equals 4x, so you got the y right there. So instead of writing the y in the second equation, you write 4x. So x minus 2 times 4x equals 56, and then you solve it. Number 7 is the same way, okay? So remember, it's the idea of substitution, and that's what you need to do. So when you get a letter by itself, or you have a letter already by itself, then you need to plug that back in and make sure that you get that taken care of, okay? Let me talk to the second class real quick, and it looks like you were on, let me look here, I got some pages that were scanned to me, so that's why I'm looking, okay? It turns out that you guys have, I think you have a 3, 1, it was a set of triangles, 3, 3, sorry, 3, 3. Similar figures and scale models, okay? So here's what you do, all right? And this should not be difficult for you. If you've got two triangles that are side by side, you need to create a proportion out of those sides and make sure that you've got, let's see if I got a pencil here. I don't think I do. All right. But what you got to do is side by side, you got to take pretend that the triangles are the same, and you got to look at, make sure you got to read the book here. Let me take a look here and see. I think it's going to be, if you guys look at 3-3, see the two triangles there? You understand that? See the two triangles there? What ends up happening is if you take AB, that's similar or congruent to what I'm trying to see what the on the other triangle. It looks the same as what the other triangle is. I can't read the letters. I think it's F, EF possibly. I can't remember. But the sides correspond to each other. So that means, let me take a look here and see if I can, there's a couple of different examples there. Go to page number 109. Go to 109 for just a minute. Take a look at the examples, and you'll notice that you've got examples on the left-hand side where those two triangles are at. And what I want you to do, let me take a look here. Write the ratio, so the one side divided by the one triangle divided by the other triangle equals, and then a different side. I don't have the close enough, but if you look at your examples, it should show you how to do the side by side and change the two triangles into a proportion, and then you can find the unknown or what the letter is. Okay, if you don't get that, then read the lesson. Or try to have either Mr. Kane or somebody explain that to you and try to help you with it. It's a little bit hard to explain when I don't have a blackboard, so I apologize for that, but I wanted to at least let you know, okay? On your homework for that, let me take a look here. All right, you're going to be doing number 3. Do number 2, number 3, number 4. Try to work on those, number 5, number 6, and I'll get back with you on those, and then we'll kind of go from there. All right. Anyway, I know this is a quick lesson. I'm not there, but hope you guys are doing well. Hope you can get those lessons, and we'll talk about them later. Okay. Thanks. Take care. Bye bye.